Good afternoon, Nick. So I've been looking at your parts and I am pretty sure that I know exactly what the most practical and also simplest solution is for you here. You have practically no dross or no burr in that sense. All you have is very, very small burr and sharp edges. And then of course you have some PVC coated parts, and pretty much all the parts have forms in them also. So that's significant, of the three different kinds. Let me show you three different kinds of machines. Maybe we first go over here. So this is a very simple machine with a belt sander. And if you look in here, see this has a single head belt sander, simply. That is what you would be using for surface graining, and you would actually get a very sharp edge and maybe a secondary burr. So this is good to remove dross, but it is certainly not good to deburr something and make the edges round and safe. Then over here, we have a machine with a deburring drum. This big drum, round drum, it's hard to see from this side, and the deburring drum is very soft on the surface, and it mainly removes material from the edge, and it doesn't leave a secondary burr, but it still leaves a sharper edge. It's not broken yet, but this can remove a lot of dross and slag, but this is more like for flame cut parts or laser cut parts which really have bad dross. And in this case we combine it with a cross belt unit, which then would take that edge and nicely round it after you have removed all the excess. Okay, so but this still is a machine that is more for the plate industry and not for 18 gauge parts, thinner gauges like yours. Then we have a machine here, and that's the second good way to edge round parts. Is again, it has a wide head sander in the front, but it doesn't need to remove dross or grain. For you that's irrelevant, but it has a rotor. So, and these spin obviously and give you some edge rounding, and then this whole carousel rotates so that they come from all directions, and it works over a vacuum belt. This works good for parts down to postcard size, and if they don't have any openings, because you need to hold the parts down with a vacuum. And these have a tendency to actually wanting to pick up a part and then subsequently of course throwing it. So it's not so much an issue of the part slipping, but it's more an issue of it being picked up and actually being tossed, and your parts would be too small for that to reliably run on this vacuum conveyor belt, which has a lot of holes. And this is also a much more expensive consumable. This is always in the conveyor belt, as a cross belt machine is, and I'll talk about that in a minute. But this is a more expensive conveyor simply because it has all these perforations in them, which cost money to put in. So I don't think that that is a good solution for you in this case. And then we have, and that's where I'm leading to, we have this very simple cross belt machine, which has an abrasive block, alternating abrasive with Scotch-Brite, and the block goes round and round on the over the part. In your case, because you have very thin gauges, you will be in the conveyor belt. That's almost unavoidable. So the conveyor belt also becomes a consumable. This is a consumable of about $2 per hour. This is a consumable in your case of about $3 to $4 per hour. And this will do your edge rounding. This will not remove a lot of dross if you had it. It would give you round dross, but not no dross. Okay. The machine works very simple. You have one belt in the front that grinds right to left. You have another belt in the back run by this motor, which grinds left to right. You can adjust the pressure of the head here, more block pressure, less block pressure, and you adjust for your material thickness here, so that your surface of the material is always at the same height, in the same plane relative to the machine. And then you have a pressure roll before the cross belt, in the middle, and behind the cross belt. And that really only holds the part into the belt until it transitions under this cross belt. And that cross belt, other than the rotor machine, pushes the part down instead of trying to pick it up. And that is why we can, with a high friction belt, hold a very small part on this machine. And other than that, it is still a brushing process, which is fairly forgiving. You don't need to adjust it very precisely. And you can do your upforms, and you could also run your PVC coated material without... Some of these parts already to start out with. This is your 18 gauge stainless steel. 16 gauge, supposedly it's really 055. It's just as close to 18 gauge as it is to 16 gauge with a small upform. We ran that at 2 feet per minute with fairly high pressure. Maybe you want to run ultimately a little bit less pressure, and we'll do that for you also. And what we do for you is we mark these parts. And as we mark these parts, we will write on there 2 feet per minute, right? And we will also then say something about the pressure. So the pressure on this one was probably plus, was fairly high. And that is really all we need to know on this machine, because the rest of it is irrelevant. What may also be of interest is, so how many parts could I run? So you could take this part and could put 1, 2, 3, 4, 5, 6 of them in a row, side by side, right? The part is approximately 12 inches long, so 24 inches gives you 12 parts per minute times 60 minutes would be 720 parts per hour. Yeah, so, and we very often we just write that on there also, 720 parts per hour. Then we tried this, which is of course very, very thin material, and you will be in the conveyor with this, and you want to touch this very lightly anyway, because just to get rid of some of this, you are not going to get a real radius on there, but you will get the sharpness out of it. Because we need to hold it, what we are doing is, you need to work with a clean conveyor. So it may be that you have to clean it up for something like this, especially when the PVC side is down. You will then, this turns your cross belt on. You will have to turn the speed of this cross belt all the way down. Not all the way, to about 40%, so that the lateral forces are lower. And you will also want to reduce the pressure that you make with the brushes on top of the part. Obviously you will be in the belt. And actually, because the part is small, you want to increase your conveyor belt speed a little bit, because you need to, that makes the transition for the small part from the pressure roll underneath the cross belt a little bit easier, and it'll hold better. And that may be then that with a small part like this, you have to run 2 passes. And as you run 2 passes, of course, with a small part like this, you could run thousands of them in an hour if you can load them fast enough or not. It's really not all that relevant whether you run once or twice. It goes very quickly if you had to run a second pass. The important part is that you can do it. And we ran the other side, and also here, of course, lighter pressure, slower belt speed, cross belt speed, gives you a break on the edge, but it does not remove the PVC. So now I'm simply going to demonstrate that to you. So these 2 parts are already complete. We'll put those to the side. We'll start with this, and then we'll move on to the small part, and we go to the large part. So this was already 2 feet per minute, more pressure. Now I have taken the pressure a little bit lighter than what we had before. Okay, so I brought it up about 20 thousandths. We're going to turn the cross belt on, we're going to turn the conveyor belt on, and we're going to run about 2 feet per minute. And what we judge when that part comes out afterwards in the back is what kind of a temperature it has. And it is sometimes better to go a little bit lighter and go a little bit slower, because that actually does a better job. Your dust collector in the end, when you install your machine, hooks up to the back in the middle, and you can either go to the right or go to the left and go to the dust collector from there. Now, as we look for this part to come out, you can already see the white line in here. Very nice. and we don't have as much temperature as before in it, so this is going to be a little bit less radius than what you saw before. But if all you're looking for is a part which is safe and people don't cut themselves, then that would be a good part. And then, so we mark it here. Very similar like we have marked this part, right? The volume, of course, would be the same, so this is 2 feet per minute. But the pressure is kind of average on this one. In the middle, not loud. So we do the second side, and then you can also see the upform. I can demonstrate that on this part. The upform is still fully intact. It is a little bit rounded, of course, and it is a little bit polished, but it is not reduced in height. So you have the full material there to thread it and to do whatever you need to do in order what you had intended for the functionality of the phone. Actually, Nick, I just realized one thing. I had my brushes at 40%. I should have mounted my brushes all the way. So, I will mark this also. That reduces your consumable, of course, significantly on the brushes. So this was brush speed. 40%. But sometimes actually the brush speed doesn't make all that much of a difference. So now we're going to run this 2 feet per minute with a brush speed of 100%. And normally in a part that size, brush speed is always 100%. There's no reason for you to go lower, of course. And then we will give you one part in about 3 feet per minute. In stainless steel, you want to go anywhere between 2 feet per minute and 4 feet per minute. And again, it depends on whether you just want to have a broken edge, it's safe to handle, or whether you really want to have a radius which paints better. You said you didn't paint those parts, so I put tape. So here we go. You can see a little bit more of a white line on it. That's the edge that we got from 100% of the speed. And then we're going to do the back side. So we're going to mark this. 2 feet per minute. Medium pressure. Yeah, something like that. And then this 100% brush speed. So, on this side, we are going to run 4 feet. As simple as that. And then we're going to run that part, both sides, at 3 feet per minute. And you can be the judge what is a better result. Sometimes more speed isn't necessarily a better result. You can save yourself a lot of conveyor belts and a lot of abrasives if you run them. So this is already, you will feel that. You see you hardly have a white line. It's safe for handling. You won't cut yourself, not at all, right? But you will see that the radius is way smaller, and therefore you have a crisper edge, not sharp, crisp. So that was 4 feet per minute. Medium pressure. Okay. So now we are going to run this at 3 feet. And you see how easy it is to set up the machine. It's only 2 dials, 2 potentiometers for the speeds, and 2 on and off buttons. That's all you need to know to operate this machine. So a little bit more than the 3 feet per minute. See a little bit of a white line here. Right? So that was 3 feet per minute average pressure. And now we're going to increase the pressure again a little bit so that you see the difference on the back side. So all we are going to do is we're going to go down a little bit. About 20,000, half a millimeter. That's all it is. And if you wanted to go light, you would go up another 20,000, another half a millimeter. And here now you can already see now the white lines are starting to become wider again. So, and the part is significantly warmer. So that's 3 feet per minute plus pressure. Of course, you can vary the pressure anywhere in between, up to you. What I'm trying to show you is that this is not super critical. So now we want to run a small part, backside first. Again, the first thing that we want to do is we want to back up a little bit here. We're going to go a little bit lighter, and then we're going to slow down here. And all we do is we go a little bit faster here, about 5 feet per minute, and we put the part on this high friction belt. If the belt gets grimy and dirty and dusty and oily and so forth, you're going to have to clean it. Normally a good clean with 409 will do. If you want to make it stickier, you can clean it with alcohol. If you have really small parts that are slipping, you can clean it with acetone. Then you will make it extremely sticky, but you also take the volatiles out of the rubber, so the belt won't last as long as if you clean it with something else. So here we go. You see the slight brush marks on the top. And this is actually too cool. I don't think that we've done enough here. So we are going to have to, so this was 5 feet per minute minus pressure. So we're going to go up a little bit with the pressure, and we are going to go a little bit slower. So belt speed up a little bit, pressure up a little bit, and 4 feet a minute. I like the manual dials because by the time you have entered stuff into a screen and hit enter and things like that, it takes longer than what we are doing here. You see that the part hasn't shifted, so we could even be more aggressive if we wanted it to. So now you will get more edge rounding. So this pressure now, so this was 4 feet a minute. And the pressure was neutral again. Okay? So we're just gonna keep on playing this game until we feel that the part is slipping on us. So these parts, by the way, have picked up a little bit of dust. You don't want that, you want it to be clean. So now we are keeping the speed. They're going a little bit harder, just a couple of tenths. And we are bringing the belt speed up to 70%. And you can see that the part still didn't slip. And now we're starting to get really nice edges on this. So this was still 4 feet per minute. Pressure now was even a plus, let's say, and 70%. I forgot to note the percentages before on the other part. So these were 40%. There we go. So now we're gonna go a little bit slower even. We're gonna go 3 feet a minute. You can see I'm kind of picking same spots on my belt. All parts of the central cord. Keep it 70%. And we go 1 notch higher. Again, the part did not fit exactly in the same spot where we were. So, and the edge gets more and more round as you feel that. That actually has on one corner a little bit of a nasty burr that you may still feel. So that was 3 feet per minute. Pressure plus. You notice something else. I also didn't change my material thickness for this because between 18 gauge and this there's really not that much difference. So from that perspective that all works. And that's 70%. So, and then the last one we're gonna go all out from this side. We're gonna go back to 100% here. And we're gonna go back to almost full pressure. What that does, and we're going to keep it at 3 feet a minute to make the transition between the pressure roll and the process. Always got a little bit of attention. See, even now the part hasn't shifted. So that is 100% belt speed and 3 feet per minute. And the pressure plus and a small plus. Okay. Now, when we do this the reverse way, this part is going to hold very good because you have the upform in it, and you see that the upform is still in it. So that by itself will hold onto the belt even though it makes the part laying high. Now, if I use those parameters, I showed you on the first part that we hardly remove any of the PVC. If I run that hard, I will remove a lot more PVC. So when you have PVC, you will probably want to run with less. It's not that it's ripping the PVC off, it's just taking more from the edge. Presumably more from the edge. Let's see where this comes from. Yeah. So now you have that here. And you see, and this may still be fine for you, but you see we have taken up to about 100 thousandths of the PVC from the edges, and that may or may not be acceptable to you. I'm not sure. That may be totally not acceptable to you. So that is run exactly at those parameters. If we go back to this now, we would reduce the pressure a little bit, right? We would still run at 70%, and we would still run at 3 feet a minute. No, sorry, we would run at 70% of course. So we would bring the belt speed down, and you can hear it by the sound that we have a lower cross belt speed here. And then we would run one part 5 feet per minute at 40% and very low pressure, and then you see again that the PVC would be fully installed. So now you see that we have still removed a little bit of PVC, but we have removed much less PVC. from the edges. Okay, so now we go to the most aggressive setting, which is 5 feet per minute, very low pressure, right, and 40% belt speed. So you have control over how much of the PVC you want to remove. In any case, you do not remove the PVC in its entirety. You will never rip it off where it gets wrapped in the machine. It will just grind away from the edges. So now here at 5 feet per minute, you can see the mark. We are removing material from the edges, but we haven't removed any of the PVC other than on this little corner where it was loose to start out with. Accordingly, I give you the other one, so that will be 4 feet a minute, and again a little bit more pressure, and 70 feet. This probably would still be an acceptable result. I don't know. See, this is about 40 thousandths off of the edge here now. Almost nothing here. So I don't know how critical this is that you can't touch it at all. At some point, if you really want to have this a crisp surface, you actually couldn't use a process like this. You would have to hit the edge directly. So, and this is the same thing here, only at 40%. Next, we are going to set up for these larger parts, which also look like 16 gauge to me. And of course, this is cold roll, so we can hit that a little bit harder to get good edge rounding, especially if you want to paint that, so that you will have good paint coverage around the edge. And here's that last part, and I think over the course of this exercise, you have realized that the parts will hold, and that you can get different results, and they are documented on this side. So, what we are going to do here, I've never really changed my material setting from 16 gauge. We are going to keep it at 4 feet belt. We are going to go full speed here, and we are going to go a little bit more aggressive like we were first on the stainless steel. So this is 4 feet a minute with the upforms up. And you can hear the brushes engage. On this machine right now, we have the new brushes where we have a slotted block, which is a little bit more pliable to inside contours versus the outside contours, so that we get a little bit better balanced result between smaller inside contours and the outside contours. The new development that we're looking at. And so here you see upforms, they're still there. They're not sharp anymore, but they're not in any way diminished. And you have a very nice smooth edge that should paint great. So that was 4 feet per minute. Pressure was plus, and you can see from the times in the video, oh, no, we're on this side, same way. So then afterwards, I'm going to show you the same thing at 3 feet and then 2 feet per minute on these parts. If you have markings, like engravings, like you have, no, this is still enough for me, on the part, also this machine will bring it out. It will enhance it. It will not in any way remove it, and so forth. Right? So, when that goes through, we're going to set this already on its way. And simply remove the steam 3 feet a minute. So the very tail end of this will run at 3 feet a minute. I don't think that that's irrelevant. What I feel here is the temperature. The temperature is nice and warm. It's comfortable to touch. In the winter, you would find that great, and in the summer, it's still not uncomfortable. So this was the sample at 4 feet a minute. Already pretty good. And then the last one, we're going to run at 2 feet a minute. And those are good processing speeds for parts like this if you want to have them ready for press. So that is 3 feet per minute. And the pressure is you see how easy it is to set up this machine. I can set up basically into the tail end of the part that I was running before. And that would be still perfectly acceptable. Also what comes across while we are doing all this is the simplicity of the machine, which not only has an effect on how you people operate it, but also has of course results for its reliability. This machine for us is extremely reliability. We have almost no warranty incidents with it, and we can give you a long reference list of people that have it. We have over 60 out in the field, and they will all confirm that the machine is by far lower in the consumables than what we originally anticipated. So now we're going down to 2 feet a minute. Than they anticipated. So from about here on, and here already at 3 feet, especially on the non-burr side, you have a great edge. So, and now we'll see the 2 feet per minute on the other part. If you wanted more radius, you could always run it a second time, of course. And then I would run that opposite in the diagonal, because then you catch different edges. Then you really get a lot of radius, which helps you. Again, this painting is not what you're looking for. So, this now here is 2 feet per minute. And the pressure was high. Go on this side, I'm going to go a little bit slower. I'm going to go same speed, 2 feet per minute, but I'm going to reduce the pressure, which will save you abrasive and which will save you conveyor belt in those thinner gauges. So we are going up by about 20,000 brushes. And you can maybe I don't know if that comes across the video, you will hear that the sound is a little bit quieter. So you can write on it now. Actually, I'm going to make a mark for you here. Right? And then you can see how much you remove on the machine, because even that, if you had something permanently marked, you could still read that as it comes out on the other side. So this part is 2 feet per minute. which seems to be slow, but if you run part after part, it's still over 100 parts per hour. And the pressure now here was average. And you can see that where we marked it, it's a little bit duller, but it's still fully visible. That's how little material we remove from the surface. If you would go onto a white belt sanding machine like this one, of course, you would remove all the material. In order to turn the machine off, you just hit this one button, because we cannot run the conveyor belt without running the cross belts, and that is so that you do not bend the cross belts over if you run something that is too thick in the machine without the cross belt running. When the brushes are running, they will always skip on the material. I have run material where I made a mistake and I was 1/8 of an inch under where I should have been, and it takes it fine. Probably 1/4 inch would still work. I mean, at some point it becomes very abusive to the abrasive. That's clear, and that's why we have the safety flap here. When you activate the safety flap, your e-stop light comes on. There are only 6 e-stop conditions. Actually 5 on the new machine. The first e-stop condition, of course, is hitting the e-stop button. You have one in the front and one in the back. That's number 1 and 2. The second one is that your safety switches, which are magnetic on this machine, for the doors aren't closed, which is number 3. And then on the back door, number 4. And then you have the safety switch here, the safety flap on the right side, and that are the 5 coils that can give you a red light upon which you cannot start the machine. So the red light needs to be off in order for you to be able to turn on the machine. Right now nothing would happen, so the moment you close that door, you can turn it on. And that concludes basically what I wanted to demonstrate and show to you here, and I hope that this was convincing. You're probably not going to like all the samples that we are giving you, but the purpose of this was to give you an overview and give you a variety so that you can then determine which ones of those are suitable. And I'm sure a number of them are suitable, and which one would be the best way to run your parts economically and with the results that you are looking for. Thank you very much.